Okay, you should have your Mechanical Advantage Lab handout in front of you. If not, just pause the video and just go grab it quickly so that way you can follow along. Now, a few key instructions that you really need to be following, and I hope you've read these for yourselves already. Okay, the first one is the information you need will be found on the pages of your textbook. So, page 113 to 120, you must read. You are expected to read that. It will help you both for the quiz as well as for the lab. Okay. Now, a few other things to keep in mind. So, that's the first point. The instructions also mention you should be using your own words. Okay. I don't want you simply to copy out what the textbook says. Okay, if you do, there will be penalties for that. Okay. I also want you to answer in full sentences. Okay, not just one or two words in your answers. And of course, since it's kind of like a math task, I want you to show all work. Okay. And fortunately for you, the work is very easy to show, so there really is no excuse for not showing your work. Now, the last thing is I'm going to kind of star these. Let's do that in blue. What are you actually submitting? You're actually submitting your results table. Okay, those are the results you found in class, as well as your calculations for the output force and your calculations for the mechanical advantage, as well as your answers. Okay, and so you're giving those two things to me when you hand them in. Okay, now some of you likely had problems with questions 3, 4, and 5. Okay, so those questions, they kind of focus on something called ideal. Oops, let's change back to blue. Sorry, change back to black. So questions 3, 4, and 5. These two focused on ideal mechanical advantage. Okay, a concept that we really didn't discuss in too much detail in class. So I understand if you're a little bit uncertain of it. Question 5, it also focused on functions of machines. Now, what I expect you to do is to go to the textbook to find the solution to those. So this is kind of not really a hint that you're thinking of, but really a hint that will help you as a student in the long run, getting used to using your resources to study. Okay, so there is a section in the textbook on ideal mechanical advantage. It lays it out very well. It even gives you an example. And question 5 focuses on the functions of machines, which we did touch on in class, but in order for you to make a better decision about what the experiment best shows in terms of the function, well, I really do again direct you to the textbook. Okay, but let's get on to question 10, because that's probably the reason why most of you are logging on. And if you're a little bit unsure, hopefully this will help you out here. Now let me very quickly recreate, hopefully, your experiments. Okay, so you had your retort stand, your kind of clip here. You had your, oh, that's not a very good drawing. You had your meter stick right here. Let's add the string here. So let's say this string, it was when it was at a certain length. Now your mass and your spring scale. Now, let's say your spring scale was here. And let's use your block of wood right there. Okay, so a couple key measurements here. Let's stick with blue. So this was where you tied in your spring scale, and if you remember, it was 95 centimeters. You didn't change that. This here is where you tied on your wooden block. That was 5 centimeters. Okay, and then this is your hinge length. Okay, now, and let's say this one here. I mean, it looks like it was about halfway. So let's just assume it was about the 50 centimeter length. But as you remember from the lab, it definitely adjusted. Okay, now question 10 says when the mechanical advantage is greater than 1, so again you have to look at your results table. to look for those specific situations where the mechanical advantage was greater than 1. The distance moved by the output force is less than the distance moved by the input force. Okay, so what is this referring to? Now, if you remember when you first started, let me kind of do this in brackets. Okay, when you first had your experiment, the ruler, this is your stand here, was probably kind of bent at a bit of an angle here, and that was because the weight was kind of hanging it down. Now, what you did was you essentially used a spring scale and you pulled it down. And when you pulled it down, again, this is the input force, well, the mass or the wooden block went up. The results, the load force, or another way of saying that is the output force, was that it went up. Now, the question is referring to the distance that it traveled. So this would be the distance of the output force. This would be the distance of the input force. Okay, so you may have to go back and read the steps again, or at least try and remember what exactly happens when you or when someone in your group pulled down on it, the actual distances. Okay, so again, the distance you pulled down, so the distance that this ruler went from at an angle to being parallel to the ground, so when it kind of went down following the direction of this arrow, that was the distance moved by the input force. And this, the resulting or the load force, the distance it went up basically from down here until up here when it was parallel, well, that is the distance moved by the output force. Okay, sorry, this is distance moved by the input force. This is the distance moved by the output force. Now, using this term, you have to kind of think back and remember. When the mechanical advantage, when the mechanical advantage was greater than 1, it was more than 1, how did the distances compare? And so again, look at that table, look at when the mechanical advantage is greater than 1, and compare that to when the mechanical advantage was less than 1. Okay? And think back to how far you had to pull down and how far up, or the distance the output force had to move that ruler. Okay? So hopefully this kind of little term helps you a little bit with your reasoning and even just helps you to understand the question. Okay. The last hint I'll give you, this is more of a guideline than a hint, to be honest. For question 11, it says, how can what you have learned from this lab about mechanical advantage be applied to the real world? Provide one specific real-life application. Now, some of you might think, oh, okay, this is pretty easy. I can say it will. Mechanical advantage makes my life easier. You might say, for example, a seesaw. Okay. Now, if you write something like that, you will barely get even a half mark for it. Because really, anybody can write this, right? Any students, even grade 5 can totally tell me mechanical advantage makes my life easier, and a seesaw is an example of that. So if you write this, do not expect a good mark for it. This is too easy. Okay? The hint down there says, or the note says, only insightful, detailed answers will receive full marks for the question. So what I encourage you to do is perhaps do a little bit of research into ways in which mechanical advantage can be used, or perhaps what you can do is do a little bit more thinking into things in your daily life that make use of mechanical advantage and how you can adjust certain things, for example, the hinge length, to help you to maximize the mechanical advantage. Now, you don't have to be limited just to kind of a lever like this. You can think of mechanical advantage for other simple machines. But for those 2 marks, I do encourage you to do a little bit of extra research, a lot more extra thinking, and hopefully you can show me some very good application of your understanding. Okay? So all the best, and I hope you have fun with this.